9, making and interpreting graphs. Uh, they give us a graph here from a personal tracker fitness, and this is calories burned throughout the day. So the problem I have here is if I'm going to be working with these numbers, I want to have the units in the same, the amount of time in the same units. So I'm going to choose minutes. You can choose hours. You can convert this to hours, but then you're going to be working with decimals. So I converted these 10 hours, which is each hour has 60 minutes. I got 10 of them, so that's 600. And then plus the 1 minute is 601 minutes. 3 hours, 3 times 60 is 180, plus 10 is 190. 1 hour, 60, plus 45 is 105. And then we have the 22 minutes. All right, number one, during what percentage, during the what percent of this person's waking hours is he very active? Okay, so we have waking hours, which, if you look at the definition here of what the data is, it's the activity breakdown excluding sleep. So this is the waking hours here. All right, question number one. During what percent of this person's waking hours is he very active? So if this is the breakdown of his waking hours, let's find, we're going to need some parts and wholes here. See, the total, of course, there's 24 hours in one day. So I'm going to convert that to minutes. And all I'm going to do here is multiply 24 times 24 hours times 60 minutes, and that'll give me total minutes. Let's see, 0, 6 times 4 is 24, 12, 440 minutes. And that's my total. During what percent of this person's waking hours is very active? What else am I going to need? I'm going to need waking hours. This is total minutes in a day. And now I need waking minutes. If I need to convert it, I know it says hours. If I need to convert it back to hours, it's no big deal. Just divide by 60. See, waking minutes, all I have to do is add these together. Let's see, 601, 105 gives me 706, 728, 828, 918. Okay, so that's waking. So sleeping is going to equal total minus waking. I don't know if I need it, but I'm going to just go ahead and do it anyway. 1440 minus 918. Let's see, that's going to be 522. Okay, so let's go back to our problem. During what percent of the person's waking hours is he very active? So my part here is going to be very active, which is 22 minutes over waking hours. Waking, I'm using minutes. 918. Put that in the calculator. I get 2.4%. So 2.4% of his waking minutes is very active. Number two, what percent of the day does he sleep? Let's see, I got sleeping minutes here is 522 out of, there's my part, my whole is 1440. 522 divided by 1440, 36.3%. 3. During which periods of the day does most of his light activity occur? Now, you gotta be careful with this as asking for it because it says which periods. So light activity, well, let's see. It's going to be the low part of the graph. So I'm going to say between, looks like maybe 11 o'clock p.m. to, let's see, it's going to go all the way to 6 a.m. Then from, I'd say 10 a.m. to 12 p.m. See, it's got another stretch here. Um, maybe 12:30 p.m. to 1 o'clock. And from 2 to 4. And one more here, maybe from 7 to 8. Number 4. What information does each graph give that the other does not? Well, the pie graph doesn't give us any of the sleeping data. It's just waking minutes. So no sleeping data. And the other tracker graph, problem with that is it's not organized. Like the trouble we had when we had to get the periods here, it wasn't really organized into groups. Call it sections. Okay, next page. Let's see. Graphs are created. Oh, this is pretty important. Graphs created to display data, which is information that we find from a source or collect from an experiment. Data that can be quantitative means that the values describe quantities can be counted or measured. That word should look pretty familiar to you because that's part of the description of this course. We deal with measured data. Qualitative is actually a little harder because it is labels or categories. It's not numbered data that we can measure data that we can use. So it takes a little bit of doing to work with it. The first graph we're going to make is the pie chart. We're going to study 3 of them here in this section, pie, bar, and line graphs. So let's look at a pie chart. Create a pie chart to display the following data about a group of college students who use 4 popular cell phone carriers. Okay, first of all, the name of the cell phone carrier is actually qualitative data. Okay. Now, the college students, we can use that the part to whole to make our pie chart. Okay, and that's a key for pie chart is to have that um, part to whole. Okay, when we describe or define um, sector of the pie chart, it is based on the percent of the sector's category it represents. Now, we're going to be doing this by hand, so it's not going to be exact, um, but we are going to be pretty close. Um, what we're going to do is, and I think we'll turn to the next page because there's a step-by-step process on how to do this. First, you're going to determine the percentage for each category. The percents should add to 100. It depends. Sometimes it's a little under or over because of rounding issues. Second step, find the measure of each sector's central angle by taking the sector's percent and multiplying it by 360 degrees. Then you're going to draw each sector using the central angle as a guide. And then you're going to label the sector with the name and the percent. Don't forget the graph, the title. All right, number 5. Ian attends a company-sponsored workshop that is designed to increase employee efficiency. His task is to create a pie chart showing how he uses his 8 hours at work on average day to help him analyze how he can better use his time. I'm going to make a pie chart. Okay, so we have categories. We have the hours. So the next thing we need to do is make a percent. It's better if they gave us more room over here. And then we're going to need the central angle. So we need percent. And then central angle. Okay. Okay, so we got a part, we need our whole. So let's go ahead and add these up to get our total or whole. So you got 1.5 plus 2.5 plus 1 plus 0.5 plus 1 plus 1.5. Gives me a total of 8. Okay, our percent or decimal, I'm going to use decimal. 1.5 out of 8. So 1.5 divided by 8.1875. And to get the central angle, I'm going to multiply by 360. 67, let's round it up to 68%. Not percent, degrees. Okay, next one, computer 2.5 divided by 8.3125 times 360, 113 degrees. Calls 1 divided by 125 times 360, 45 degrees. Breaks 0.5 divided by 8, 0.0625 times 360, 22.5 degrees, or 23. Let's just call it 23. Let's see. Much 1. We have a 1 already up here, so it's going to be the same. 0.125. Need a different color. 0.125 times 360 is another 45 degrees. And then 1.5 was the same as meetings. So I'm going to use 0.1875 at 68 degrees. Okay. So now with our central angles, and again here, I'm just roughly using it as a guide. So I need a 68%, which is not quite 90. Here's my center. Not quite 90. So I've got my 68%. See, half of that would be 45, so maybe here. And that's going to be my meetings. That's 68%, or 68 degrees, or 18.8%. Okay, next one. 113 degrees. So that's 180. That would be 45. 65, not quite 180, maybe 113 might be here. It still seems pretty good. Here. It's going to be my computer. And that was 31.3%. Actually, well, that's okay. I need a 45 degree. There is 90, so half of 90. See, columns. And that was 12.5%. Next one, breaks. Yeah, it was 45. It's only a 23 degrees, so that's pretty small. 3 degree. That was breaks. And that was 6.3%. Lunch was a 45. Central angle of 45. So lunch. And that percentage was 13.5. And then another 68, which actually is not that bad. Came up pretty decent. Sector. See, off task. And that was 18.8%. And I need a title. So, Company went designed to increase his task, and showing how he uses 8 hours of work. We'll call this use of 8 hours at work. The title. Okay, next graph. Another way to display data is with bar graph. If we align those bar graphs from highest to lowest, tallest to shortest, we get what's called a Pareto. So, bar graph, and when you organize it from highest to lowest, it becomes a Pareto. Okay, it says create a, well, this is actually their example. We're going to actually do a problem creating a Pareto. And here's the step-by-step process. Determine the categories and the values to be graphed. Draw and label the axis. Use the values to draw and label tick marks on the vertical axis using consistent increment. Draw vertical bars, either touching or spaced evenly on the horizontal axis. Use the tick marks on the vertical axis and category values to determine the height of each bar. Write the name of the category under each bar, and then give your graph a title. And then the last graph is the line graph, which is nothing more than a series of connected paired data points. So what you do is you plot points and then you draw the lines. Let's go ahead and answer these questions. The data that accompanies over-the-counter prescription drugs is full of important, often mathematical information. In the following graph, the vertical axis represents the concentration of acetaminophen in the body, measured in micrograms per milliliter of blood, mg per ml. The horizontal axis represents the number of hours, and the graph is constructed in a way. The graph is constructed in this way because the amount of acetaminophen in the bloodstream depends on how much time has passed. Since all the data values are positive, only first quadrant of the graph, because quadrant 1 is all positive, is used. Use the line graph to provide the answers to the following questions. Okay, A, write the ordered pair for the point indicated by the arrow and interpret it. Do not use abbreviation. No, we are going to use abbreviated. No reason not to. Okay, here's the arrow. That means we go along the horizontal axis first. We get 2 hours. And if we go up, we have 12 milligrams per milliliter. So there's my point. Use the shape of the graph to describe what happens to the concentration of medicine in the body over 8 hours. So let's do that first. Okay. During the first 8 hours, goes up rapidly, then starts to decline to a gradual, pretty quickly. So let's do that. The graph rises sharply. Let's say for a half hour. then falls, declines, moderately, for until about the 4th hour mark. So for 3.5 hours. Then it's more of a gradual declination and gradually tapers off. Okay, second part. Why is a second dose needed after 4 to 6 hours? Because of that moderately declination here. So it actually gets out of the blood system quite a few amounts. So you want to increase that back up. So let's say because you need to bring that level of acetaminophen I'm going to abbreviate it, in the bloodstream back up. C. When do the formulations result in the same concentration of acetaminophen in the bloodstream? Well, here's the extra strength tablet is the dotted. The blue one is the liquid, but they both seem to converge at 4 hours. So after 4 hours. D, based on the graph, which would you take for pain relief, liquid or tablets? I would take liquid because it's very quickly in the bloodstream. To relieve pain. And E, liquid dose is listed at 500 milligrams per 15 mil. Okay, so 500 milligrams per 15 milliliters is equivalent to, well, actually, that is, I got it in parentheses here, 1,000 milligrams. That means there's 500 milligrams of acetaminophen for every 1,500 milliliters of liquid. If 15 milliliters is equivalent to 1 tablespoon, so that is also equal to 1 tablespoon. How many tablespoons do we need to ingest 1,000 milligrams of liquid medication? They're trying to mess with you here because it's a trick question. It's like if A equals B, B equals C, then A equals C. 1 tablespoon. And here's the step-by-step process to make a line graph. I'm not going to read this one out. You can read it on your own. And then connect, they give you a whole bunch of information here. And they ask you to make a chart, either pie, bar, or line. There's so many different answers for this. I'm not going to go do this. So this one you can also do on your own. That's it for 1.9.